This is number one of the AP Calc BC FRQ questions in the 2025 exam. I don't know if that sentence even made sense. It's late in the night that I'm recording this. I know I'm late to the game, but if any of my followers are interested, here are some videos of me solving the response questions of the 2025 exam. I believe most of my followers are not actual students. They're actually graduates or instructors, or I don't know. I feel like at least the people who write comments and all that don't seem like students learning this for the first time, which is interesting. But anyway, if any of my followers are interested, here is number one in this video. Okay. So what does the question say? It says an invasive species of plant appears in a fruit grove at time t equals 0 and begins to spread. The function c, defined by c of t, is the sky, arctangent function, models the number of acres in a fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t is the sky. Okay. Find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. Show the setup for your calculations. Okay, so by the way, number 1 and 2 are the calculator required or allowed, or some of it is required actually, questions. Okay, so this is asking for average number of acres. Which function is the number of acres? It's c, number of acres. C prime is rate of change of that, okay? So we want to find the average value of c of t on 0 to 4. Do you remember how to find the average value of a function? That's 1 over the time stop minus time start. So 4 minus 0, integral from time start to time stop from 0 to 4 of our function of interest c prime. It's not c prime, sorry. C of t dt. Okay, put this in the calculator. Your answer should be 2.778. Personally, I would put the units. I know sometimes in the recent years, they don't dock off points if you don't put the units, but I would put it just in case. It's just by habit. So 2.778 acres. Okay, and if you followed along in other videos before, I've mentioned before that I would keep at least 3 decimal places. Okay. Okay, part B, find the time t when the instantaneous rate of change c equals the average rate of change of c over the time interval from 0 to 4. Show the step for your calculations. What is average rate of change and what's instantaneous rate of change? Instantaneous rate of change is the derivative. That's c prime. Okay. Now what's average rate of change? Remember, even before you learned derivatives, you probably learned how to find average rate of change, how to do that. That's just the slope between the 2 points, okay? So average rate of change is c of 4 minus c of 0 over 4 minus 0. As I said, it's the slope between the 2 points, okay? And instantaneous rate of change is c prime. Set them equal to each other because we're interested to find the time t in c prime when it's equal to the average rate of change, okay? So c prime t is that guy, as I said, which c prime is, they give it to us right there. So but this says y1, this is y2 in your calculator, find the point of intersection. That's 2.1543. So the answer is 2.154. And again, I would put the units weeks. Time is in weeks. So in the intro over here. Okay. Part C, assume that the invasive species continues to spread along according to the given model for all times t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. I believe they even put this word end behavior in this exam because they assumed that most students took AP pre-calculus. Honestly, when I learned about limits, I never really encountered the term end behavior. Only ever since I've tutored students last year in AP pre-calculus, they started talking about end behavior. So that's how, honestly, I came more across it. You know, I know what it is, just from the name of it, in 2 words, but I'm just saying when I learned about limits and limits to infinity and negative infinity, I didn't learn as end behavior. But anyway, so that's probably why they started using this terminology here. Okay, so as I just said, as I was ranting or rambling, end behavior is limits as, in this case, t approaches either negative infinity or positive infinity. As we go toward the end of time or the beginning of time, that's what end behavior is, okay? So in this case, it's asking about the limit as t approaches infinity because, first of all, t greater than 0, so it has to be positive infinity, okay? And then this is basically saying as time keeps going on and on and on. So that's as t approaches infinity. You can't go backwards in time, really, right? Unless you want to analyze that, but that's not what it's asking here. As time keeps going on, not as time keeps going backwards, okay? So what's our expression? It's limit as t approaches infinity of c prime of t dt. It's asking for the limit of the rate of change, which is c prime, okay? Now we evaluate this limit. I don't think you need to show that much work, honestly, because you could show the work of dividing or factoring out the t squared. And then actually you don't even need to factor here really, but take the limit and it's a 0. This should be good enough in my opinion. Okay. We'll see when the scoring guidelines come out, but that's it. That's all you need to show here, probably. Okay. And then part D, at time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function A defined by AT C of t minus this integral. This should look suspiciously familiar as to what technique we might have to use. Models the number of acres affected by the species over the time interval t is 4 to 36. At what time t, for t is between 4 and 36, does A attain its maximum value? Justify your answer. How do we find max min? Derivative, right? We find when the derivative changes sign, first derivative specifically. Okay, that's one way to do it. So we want to differentiate A over here. And that would get a c prime of t minus, I was mentioning here, this should look suspiciously familiar as to what technique we have to use. We got to use fundamental theorem of calculus. How do we differentiate this with respect to t? You just, because this lower limit is constant, you can just plug in this, and this upper limit is just t. You just plug in the upper bound as x. That's it. Okay. So a prime t is c prime t minus 0.1 times ln of t. That's what I was saying, okay? Fundamental theorem of calculus. You can go back and review that if you need to. I probably have videos on this as well. So we want to graph a prime t and see where it goes from positive to negative. Earlier, I believe I said we want to find when a prime changes sign because there's maximum in there. Specifically, because we want to find where there's a max, that's when a prime, the derivative, changes from positive to negative, okay? So you would set your axis properly on your calculator. You know it's between 4 and 36, so you can just limit it to that. And you find where it crosses from positive to negative, you'll find that it's 11.4417. Don't forget your units, t, for t, which is weeks. Okay. I peeked at some other people's solutions already, just to even cross-check my answers. They started putting in tables to show that a prime changed from positive to negative. You could do that. I honestly, from looking at scoring guidelines before, if I remember correctly, if you just state this, it should be fine. You don't have to show a whole table. Because technically, if you show a table, you have to prove that this a prime is, first of all, continuous everywhere in that interval, and it's monotonic. Okay. So a table is risky in my opinion, unless that's what they require nowadays, then do it. Honestly, I don't know, but I haven't looked too much into details. But honestly, from a conceptual point of view, this is the explanation. Okay. All right, that's it for number 1. Hopefully this was interesting or helpful. If you're watching this in the future and you're trying to study for the AP exam or some other exam, please give this video a like if you found it interesting or helpful. And hopefully I'll see you in number 2 or whatever number I film next.